number 6. Draw the Lewis structure for methane, which is CH4. According to VSEPR theory, what is the molecular geometry of methane, and what are the predicted bond angles? Okay, so when writing out the Lewis structure, we first need to calculate the total number of valence electrons. Carbon has 4 valence electrons, and hydrogen has 1. And since there are 4 hydrogen atoms, we multiply this number by 4 to give us a total of 8 valence electrons. So now, when writing the skeletal structure, I'm going to write carbon as our central atom, and then I'm just going to form 4 bonds with my hydrogens. So the reason why carbon is our central atom as opposed to the hydrogen is because carbon is able to make multiple bonds. Hydrogen is only able to make a single bond because it only has 1 valence electron to participate in the bonding. Okay, so now I have this structure for methane, and if I count out how many electrons I've drawn so far, where each bond contains 2 bonded atoms, then I have my 8 electrons already in the structure, so this would be the correct Lewis structure. So for the second part of the question, according to VSEPR theory, what is the molecular geometry of methane and what are the predicted bond angles? So we need to analyze our central carbon for this structure, and we'll see that the carbon has 0 lone pairs, and it has 4 bonded atoms. So if we use a VSEPR theory table, like this one, we can find out a lot of things about it, like its molecular shape and its electron geometry. So when we have 4 bonded atoms and 0 lone pairs, we have a tetrahedral molecular shape and electron geometry. So I'm just going to write molecular shape and electron geometry is both tetrahedral. Okay, so since there are no lone pairs on the carbon, we would have the same molecular shape and electron geometry. And the carbon would be sp3 hybridized. And the predicted bond angles are around 109.5 degrees. Okay, so now let's see what the junior tutor said. For us to use the VSEPR theory, we need to first write the Lewis structure of the molecule. The molecular geometry of a molecule can be determined depending on the number of bonds present and the number of lone pairs present in the central atom. For molecular geometry has also its predicted bond angles for the molecule. The methane molecule will have carbon as its central atom with the 4 hydrogens bonded to it. Carbon has 4 valence electrons, while each hydrogen has 1, and the valence electron of the hydrogen will be shared with the central atom, which can be represented as a single bond. Hence its Lewis structure is the following. So using VSEPR, it has tetrahedral molecular geometry with bond angles of 109.5 degrees. Okay, so this solution is correct.